Hello students, today we are going to start a new chapter under the unit number 1, that is data handling 2, and the chapter name is Numpy Array. So today in this session we will finish the revision of the Numpy Array completely. So let's get started. Okay, so we will start with the introduction. What is the Numpy array? As you all know that Numpy is a numerical Python. It is a library that is basically used for scientific computing in Python language. It provides a array object and various tools to perform certain operations on the array object, like joining of the array objects, or splitting of the array objects, slicing of the array objects, and reorganizing of the array objects. All these such kind of the operations we can perform using the Numpy library, and its full form is numerical Python. Generally in a 1 or 2 mark question may be asked that what is the Numpy, and you will say that Numpy is a numerical Python and it is a library basically used for scientific computing in the Python language. So the first question that arises in the mind is, how can we install this library? As you know that any library in a Python can be installed using the pip command. So we will write pip install numpy to install Numpy on your fresh computer after installing the Python. So 1 mark question may be asked, write a command to install the Numpy library in your computer. So you can use this command pip install numpy. Next, after installing the Numpy, how can we use this Numpy library in your Python program? So this also might be a 1 or 2 mark question may be asked in CBSE, that which command or which Python statement we use to import the Numpy into the Python program. So the statement will be import Numpy or import Numpy as np. You can use both these statements. Now we will see the types of the Numpy array. So Numpy array basically has two types. One is one dimensional and another is two dimensional. One dimensional means already it has only one dimension, like this. It does either it will have a one row and multiple columns, or it might have a one column but multiple rows. So these two structures are the examples of the one dimensional Numpy array. Numpy array may contain data like this: 1 2 3 4, let's suppose 1 2 3 and 4. Now the index will be look like this: 0 1 2 3. As you always know that index of the Numpy array always starts with the 0. There is also a negative indexing that starts with -1 from the reverse side: -1 -2 -3 and -4. So this is the example of the one dimensional Numpy array having one row and 4 columns. The size of this Numpy array will look like this: 4 comma blank. The one dimensional Numpy array size will be represented like this only. Okay, now the another way of representing Numpy array like this. This one is also 0 index, 1 2 or 3. It has a negative indexing also: -1 -2 minus 3 or minus 4. Now the size of this numpy array is also, how many elements are there? 4 comma like this. This is the representation of the numpy array that has the one dimension. Now we will look at the numpy array of one dimensional is also known as vector. This question may be asked in 1 or 2 mark question. What is the other name of the one dimensional numpy array? Then you will write vector. Example, you can write like this. How can we create the numpy array in Python? We will discuss in the subsequent slides. Now what is the two dimensional numpy array? The numpy array which has the multiple dimensions like this, 1, 2, or looks like this. So this is an example of one dimensional array. It has some data like 1, 2, 3, 4, 5, 6. It also has an index number 0, 1, 2. This is the column index and this is the row index 0 and 1. So it has how many rows? 2 rows. Rows are known as this, 1 row and 2 row. And how many columns? These are columns, 1 column, 2 column and 3 column. So 2 comma 3 is the shape of this numpy array. So it is an example of two dimensional numpy array. Okay, so the other name of the two dimensional numpy array is also known as matrix. You might have heard the name of the matrix in your secondary classes. If you have science stream, then it might be possible that you have heard it into your 11th class mathematics. Okay, so let me move ahead with more Python related codes. Okay, so in this slide we will see how can we create a numpy array in Python. So as in previous slide I have already told that how can we use the numpy array into our program. So this is the line you need to write mandatorily for using the numpy array. So import numpy as np, then we can create the numpy array using array method of the numpy library. So this is the array method and this belongs to this numpy array, that's why we are writing it np dot array. Then we will pass the one dimensional list and then it will create a numpy array of one dimensional. So what this code will do, it will create a one dimensional array, looks like this, 1, 2, 3, 4. So index will be very similar like list 0, 1, 2 and 3. Okay, negative index is also generated at the same time. These indexes will be used when we will access the values from the numpy array. So keep this in mind. So if we print this a1 variable, we are creating the numpy array using this line and then we are holding this numpy array into variable a1. Now if we print the a1, the numpy array will be printed. As if we print the numpy array, it will not display the index number to you. This is only for your convenience or to clear your concept in mind that index number is there but it is not displayed while you print it on the computer using this print statement. Okay, if you want to know whether it is array or not, you can write this command type of a1. If you write like this, then it will return to you the type of this array, that is nd array. Like this you will get in the output. That means the type of this data or this array is n dimensional numpy array. Okay, so this is how you can create the one dimensional numpy array. Okay, let's move ahead. Now we will see some more examples of how can we create the numpy array. we will see different ways to create the numpy array. So let's see all those ways, because the question may be asked on this thing that the examiner may ask you that he will give this statement and ask what will be the numpy array created by this, or the examiner may ask vice versa, like he will or she will give this output and he will ask that how can we create this output using the numpy array, numpy library. So you need to know that how can we create the numpy array, various kind of numpy arrays using numpy library. So we will see all those numpy arrays creation in brief. So let's suppose we need to import numpy as np for working with the numpy, as we have already discussed. Now we want to create a numpy array with this, like with this line, it will, what it will do, it will create a one dimensional numpy array with values 500, 12 and 30, as we have already seen similar kind of example in our previous slide also. Okay, so it will print 500, 12 and then 30, then 30. So this will create a one dimensional array using array method. Okay, now if you want to check what is the rank of this array, rank of the array means how many number of elements are present in this array. So how many number are present in this array? 3. Actually we will say that what is the shape of this array in the rank. Then we are printing the shape, a dot shape. In the rank we will say it is a rank 1 array, because how the rank is the how number of axes are there in the numpy array. In one dimensional array always there will be a one axis, so the rank of this numpy array will be 1. Okay, keep this in mind. And shape of this numpy array is that how much, there are 3 elements, so we will denote it like 3 comma blank. Now if we want to create the empty numpy array without any data, then what we will use, we will use this empty method. Empty with a single number n will generate the numpy array of one dimensional with n values. So it will generate the 5 elements numpy array, 1, 2, 3, 4 and 5. 5 elements numpy array, and each element will have the garbage value. Garbage value means it may have any value, there is no restriction, like it may have 1, 2, it may have 100. Garbage value, any value, it may have 98, it may have 2, it may have 3, like this. It will have a 5 elements but any value, garbage value. Okay, so this is the example of empty method. If we use the zeros method, what zeros method will do, zeros method will generate a numpy array of 7 elements with all values 0. So it will generate a numpy array of 7 elements with all values as 0. So this is 1, 2, 3, 4, 5, 6, 7. All the values will 0. 1, 2, 3, 4, 5, 6 and 7. This looks like this. Then we will have the ones method. Ones method will return the numpy array of elements 4 with all the values as 1, because name of the method is also suggesting ones means the numpy array with only one value. So this will be the 4 values, and all these 4 values will be what, 1. Okay, so this is the numpy array creation, one dimensional numpy array creation with all the values as 1. Now next is the numpy arrays creation with random values, and the range of the values will be between 0 to 1. The range of the elements will be between 0 to 1. So it will create a numpy array like this. It will create a numpy array like this: first, second, third and fourth, and each value will be between 0 to 1. Always keep this in mind. What is the difference between the numpy np.empty and np.random.random4 is that empty method will also generate a numpy array of the same 5, but it will have the garbage values, or the range of the values will not be there. It may be any value, but in case of the np.random method, the range of the values will be between 0 to 1 only. If you see here 0.19, if you see here 0.40, if you see here 0.18, if you see here 0.26. so keep this in mind. Now we will see another example, np.full 5,3. so 5,3 means we have to create a numpy array with how many elements? 5 elements, and each value of this numpy array will be 5. so this is the question. If you want to, let me give you some brainstorming question. You need to just comment in of this video that I want to create a one dimensional numpy array with all the values 1, but I don't want to use the np.ones method. So you need to write down the equivalent Python statement in which you need to create a one dimensional array of 4 elements, but you are supposed to not use the ones method. So you need to use any method to create the numpy array of one dimensional with each value as 1, but you will not use the ones method. So keep this and comment in the comment box of this video. Okay, I will see and look at this how much you have understood. Now we will see another method to create the numpy array of one dimensional using range method. So range method is basically a range method. Like range method, you have seen it or learned it in your class 11 in chapter list. Range method, it is a range method. A range method will take 3 arguments. Start, it will take 3 arguments, start, then stop, then it will take stop, then it will take step. So it will have 3 arguments. If there is no step, then it will be by default it will be 1. If don't have the start value, it will by default it will have the 0. If you don't have the stop value, then it will always have the end of this numpy array. Numpy array end means last element of the numpy arrays, and step if don't have, then the 1 will be the default value. So if you don't pass anything and just only pass one value, then it will be the it will generate up to 0 to n minus 1 element. So np.arrange will return like this. It will create a numpy array of the 4 elements, and the array elements will be starting from 0 to n minus 1, that is 4 minus 1, that is 3. So it looks like this. So it will generate the numpy array of one dimensional array starting from 0 to 4 minus 1, that is 3. Now we will have this example. This example will have the start value 5, stop value 20, and after each value starting from 5 we will add 3 into it. Okay, so let's see how it will create the numpy array. I am creating here. Okay, so we will have this like, how much elements will it have? 5, then 5 plus 3 8, 8 plus 3 11, 11 plus 3 14, 14 plus 3 17. Up 17 plus 3 20 will not be there, because it will generate the numpy array with values 20 minus 1 means 19. So if we add 3 more, then it will become 20. So we will stop at the 17 only. So it will create a numpy array 5, 8, 11, 14 and 17. You can see this here also, 5, 8, 11, 14 and 17. Okay, so let me move ahead. I hope you have understood it. Okay, so now we will see the two-dimensional NumPy array. We have seen the one-dimensional array NumPy array and how can we create the one-dimensional NumPy array. We have seen that concept so far. Now we will see how can we create the two-dimensional NumPy array. Two-dimensional NumPy array, as we already know that it has some rows and it will have some columns also. So let's look at this. Let's suppose this has this 2 rows and 4 columns. Let's suppose it has 1, it has 2, it has 3, it has 4, it has 5, it has 6, it has 7, it has 8. So it has the 2 rows and 4 columns, 0, 1, 2 and 3. So it will have 2 rows and 4 columns. So this is the shape of this NumPy array. It is a two-dimensional NumPy array. If you want to create something like this, we will use this method only np.array, but we will pass the two-dimensional list into this argument and we will be having this two-dimensional NumPy array. Let's suppose we will represent this example only. So this example will look like this. It has the 2 rows. 2 rows means this row, this will become the first row because this is the one list, and this will become the second row. So 10 will become the first element, then 11, then 12, then 13, then 21, then 22, then 23, then 24. This is the NumPy array. Now it has the index 0, it has the index 1, it has the 0, 1, 2 and 3 index. Now it is saying that we want to access the element first row and third column. So the first row and third column, first row is what? 0, 1. 1 index is what? This, and 3 index is what? This. So which is the element? This first index 24 is the element. It may be accessed like this with comma values, row number, comma, column number. It may be accessed like this also, A, then row number, then bracket close, bracket open and the column number. Using this method also you can access the value of the two-dimensional NumPy array. Okay, so let me move ahead. We have already tell what is the shape of this NumPy array. Shape is basically what? Number of rows comma number of columns. Number of rows is that 2 and number of columns is 3. That's why the shape of this NumPy array will be 2 comma 3. So this is the example. Another example, let's read this. A dot shape and 2 comma 4, then item size is 4. Item size means what is the data type of this? Integer. So integer data type, then we will have the 4 bytes. Okay, keep this in mind. Let's move ahead. Okay, now we will see how can we create the two-dimensional NumPy array using reshape method. Okay, so reshape method, let's suppose, is used to create a two-dimensional array from the one-dimensional array. Let's suppose we have one-dimensional array of size 6. Let's suppose we have the one-dimensional array of size 6, 3, 4 and 1, 2, 3, 4, 5 and 6. Let's suppose we have this NumPy array of one dimensional 22, 33, 44, 55, 66. Let's suppose we have the NumPy array of this dimension. Now we want to convert this NumPy array into two-dimensional NumPy array. Then how can we convert this? Then it has the 6 elements. So reshaping doesn't change the number of elements. Keep this in mind. While reshaping, you should never change the number of elements in numpy array. You can change the shape of the numpy array. Okay, so how much of 6 means either you will have 2 rows or 3 columns, then you will have the 6 elements. Either you can reshape like 3 rows and 2 columns. So these are the two ways. One is another possible, but 1 comma 6 1 comma 6 is another possible, and 6 comma 1 we will have the shape only possible if we have the multiplication of the number of rows and number of columns should be the number of elements in the one dimensional array. Then only this one dimensional Numpy array will be reshapeable. So 2 cross 3 is 6, reshapeable. 3 cross 2, reshapeable. 3 cross 2 will look like this. It will only have the 6 elements, but shape will be different like this. This is the shape. Okay, this is also possible, but these two shapes will be one dimensional array, so we will not cover these, but we will have these two. So how much? 2 rows and 3 columns, the values will be 11, 22, 33, 3 elements, then 44, then 55, then 66. Or this will also have 1 1, 2 2, 3 3, and 4 4, then 5 5, and then 6 6. Look like this. So this is how you can use the reshape method to convert the one dimensional array into two dimensional array. Question may be asked. Keep this in mind. Okay, thank you. Let me move ahead. Okay, now we will see the concept of slicing of the Numpy array. Slicing means process of extracting a subset of elements from the existing array and the returned result of the another array, possibly of the different dimension from the original. Slicing means, let's suppose this Numpy array has this much element. Let's suppose 1 2 3 4 and 5. Let's suppose this Numpy array has this much element, 1 2 3 4 and 5. Okay, and now if we want to extract this the 2 comma 3 comma 4 from this Numpy array, then we will use the concept slicing, because slicing means extracting a subset. Subset means we will extract some portion of this Numpy array into some another Numpy array. This concept is known as slicing. So we will have the slicing concept, and we will see how can we use this slicing concept to extract the different values from this Numpy array. Okay, so we can use this method. We will have the 3 arguments to extract the Numpy array. Start value from which we want to extract, then stop value up to what value we want to extract, and the step means how much values, like if you want to access the we want to extract the all the regular values from starting to stop position, then you will have the step 1. If you want to extract the every second values between start to stop, then we will use the step as 2. So keep this in mind. Similarly, we can use the array slicing for the two-dimensional Numpy array also. Two-dimensional Numpy array, it will be very similar to one-dimensional array. If you know the one-dimensional Numpy array slicing, then it will be very easy for you to understand the two-dimensional Numpy array. Let's suppose one-dimensional Numpy array has 1 2 3 4 5 6 7 and then 8 and then 9. Okay, we will have some index like this 0 1 2 row index, and we will have the column index 0 1 2. This is known as the row index, this is known as the row index, and this is known as the column index. Now the slicing will work like this. first portion of this numpy array slicing will be to filter or slice the rows, and second portion of this numpy array is used to filter the columns. Okay, so keep this in mind. So if you want to access the values 5, 6, then 8, 9, then how you will be extracting? You will extract the first row and second row, and then in which column? First row, first column and second column. First row and second rows, first column and second column we want to extract, then we will use the two-dimensional numpy array slicing. We will see more examples in the subsequent slides. I have just covered the concept here. Okay, so let me move ahead. We may have also have the negative indexing, -1, -2, -3. So we can also have the negative index slicing -1 to -3. Okay, we will see in the next example. Okay, so we will see here see some examples here. So let's suppose this is the numpy array. The numpy array is given like this. This is the 3 cross 3 numpy array, means two-dimensional numpy array of 3, 3 shape. So it will have the value like 1, 2, 3, then we have the 4, then we have the 5, then we have the 6, then we have the 7, we have the 8, we have the 9. Okay, now let's suppose it has the index 0, row index 1 and 2, negative index if we see -1, -2 and -3. Keep those separate so that you don't confuse, like this. Now it will have the column index 0, 1 and 2, similarly negative index -1 and then -2, then -3. Okay, we have separated like this. So if you want to, let's see with this example, this numpy array will have look like this. Now this is asked a colon 3, then 1 colon 3. What will be the output? First we will look the values that filters the rows, and then we will look the values up from the right side of this comma to filter the columns. So how, which rows will be filtered? As we know that starting value is not specified, and but stop value is specified, and stop is not specified, so the step will be, start is by default start is 0 if not specified, stop is specified as 3, and step is specified as 1. By default it will be 1. Okay, so starting from 0, so 0, 1, comma 2 rows will be selected. Okay, and which columns will be selected we will see here. So start position is specified is what? 1. Stop position is specified what? 3. And step is specified what? By default there is no step specified, so by default it will be 1. So which rows, which columns will be filtered? Starting from 1, 2, 1, 2 column will be selected, because it will stay, it will select only up to stop -1, as we have seen in here, up to 2 only, because stop -1 up to stop -1 is always selected. So 0, 1, 2 row, 0, 1, 2 row is what? 0, 1, 2 row is this, and 1, 2 column only. So this portion of this numpy array will be selected, this portion. So the output will be 2, 3, 2, 3, 5, 6, and then 8, 9. So the output will be look like this. Okay, as you can see here. Okay, let me move ahead. We will see another example. I am just roughing it. Now let me see colon 2 and comma colon 2. So which rows will be selected? We will see from the left side. Start is not specified, so start will be 0. Stop is specified, so stop will be 2, and step is not specified, so by default step will be what? 1. So which rows will selected? 0 and 1, because up to stop minus 1 is always selected. So 0 1 row will selected. Similarly there is column 2 at the for column filtering, so same way 0 1 column will be selected. So 0 1 row and 0 1 column. So what will be the output? 0 1 row and 0 column, 1 2 4 5. So output will be look like this: 1 2 4 5, like this: 1 2 4 and 5. 1 2 4 5 will be the answer. Okay, so if you print the A3, so like this is the answer. Now we will see another example: 1 colon 3 colon 1. 1 colon 3 means starting is what? Starting is 1, stop is 3, start is 1, stop is 3, and step is not specified, so step will be by default 1. Step will be by default 1. So which rows will be selected? Starting from 1 and 2 rows will be selected only, because up to stop minus 1. Stop minus 1 means 3 minus 1. So 1 2 row will be selected, and which row columns will be selected? Colon 1. Colon 1 means start position is specified is what? 0. Start position is 0. Stop position is what? Stop position is what? 1. And step is also 1. So up to stop minus 1 will be selected. So stop is 1, 1 minus 0, 1 minus 1 is 0. So only 0 column will be selected. 1 2 row and 0 column. 1 2 row and 0 column will have the value 4 7. So output will come like this: 4 7. Okay, so keep this in mind. Now we will see some more concepts in next slide. Now we will see the concept of splitting. Splitting means to get contiguous subset. We have splitting means, like we have this numpy array of one dimensional array or two dimensional array. We want to split this numpy array in such a way that two numpy array created of two different shapes. For that purpose we use the splitting, and we will have three methods for splitting: split method, horizontal split, and vertical split. We will see the syntax and functioning of all these three functions in the next slide. So the syntax will be of the hsplit means horizontal split. This, let's suppose this is the numpy array and this is the numpy array. Let's suppose of the 4 cross 4. Let's suppose this is the numpy array of 4 cross 4, and we want to split horizontally matlab this way. This portion is one numpy array and this portion is another numpy array. So this is known as horizontal splitting. If we want to split like this portion of the numpy array is one numpy array and this portion of the numpy array is another numpy array, then this kind of splitting is known as vertical split. So we will see those concepts in detail with example in the subsequent slide. We will pass the n as argument to split in how much numbers. Let's suppose in this example we are splitting horizontally or vertically in two numbers. This numpy array into two parts. So keep this in mind. So where n is the number of division in the given numpy array, and the array must be equally divisible in n parts. Let's suppose this is the 4 and we can divide this numpy array into two parts of 2 plus 2, 2 plus 2, okay, so that we get the actual size of the numpy array. Okay, if we don't able to split, let's suppose 4 size numpy array, 4 rows or 4 columns numpy array cannot be splitted like this into 3 parts, because it will not have the contiguous location in that case. Okay, so we will see this with example in the next slide. Now we will see this numpy array. Let's suppose this is the numpy array that is given. Let's suppose we have this numpy array. Let's suppose this is 1, this is 2, this is 3, this is 4, this is 5, and this is 6, this is 7, this is 8, and this is 9. Now this is 0, 1, 2, 0, 1, and 2. Okay, now we want to horizontally split this numpy array into 3 parts. Horizontally means this way: 1 part, 2 part, and 3 parts. So if we want to split it horizontally, we will use the hsplit method. Okay, and into 3 parts, then we can easily split into 3 parts because it has the 3 number of columns, so we can easily split into the 3 parts. Like these 3 parts we will be able to split. So the output will be 147, 258, and 369, because we are able to split it horizontally. Okay, so this portion is one portion, and then 258 is the another portion. 258 it will be the another horizontal division, and 369 is the another division. We cannot split this into the 2 parts because three rows cannot be splitted equally into the 2 parts, because 1.5 is not possible in the numpy array. Okay, size. That's why the numpy array number of rows, if we are horizontally splitting, the number of columns into numpy array should be completely divisible by the number of parts in which you want to split. Okay, keep this in mind. Now we want to split vertically. Vertically splitting will happen like this. This is the vertical split. So 1, 2, 3 will be one portion, 4, 5, 6 will be the one portion, and 7, 8, 9 will be the one portion. You can see this 1, 2, 3, 4, 5, 6, 7, 8, 9 in output. So it will split like 1, 2, 3 will be the one portion of the array, and then 4, then 5, then 6 will be the another numpy array, and 7, 8, 9. 7, 8, 9 will be the another numpy array. So this way you can split vertically. We can use the vertical split. In case of vertical split, number of rows should be completely divisible by n. This number n, here it is 3. Otherwise splitting is not possible and error will be thrown. Now we will see the example of the split method. Split method can be used to split the numpy array in a non-contiguous way or different size of the. In this hsplit vsplit, we will see that every split of the numpy array will have the same size and same shape only. But in case of the split method, we can have the non-contiguous size splitting, and we can have the different shape splitting using this split method. We will see this with example in this slide only. Let me clear this window first and then we will see. Let's suppose this is the numpy array. This is the numpy array. We have already know this. Let's suppose this is the numpy array, and we have the values like 1, 2, 3, then we will have the 4, then we will have the 5, then we will have the 6, then we have, let's suppose, 7, then we will have, let's suppose, 9, 8, and 7, 8, 9. We have the indexing 0, 1, 2, and then 0, 1 and then 2. Now what will happen, we in this case of split method we will split like this. 1 comma 3 may be written as like this, 0 to 1 will be one split, then 1 to 3 will be another split, and 3 to up to end element will be the another split. So we will have this split row wise, because both axis argument of this split will be by default 0, so it will split row wise. Okay, so 1 to 0 to 1, 0 to 1 means 0 to 1 minus 1 means 0 row will be selected, so 1 2 3 will be print. Then 1 2 3, 1 2 3 means 1 and 2 will be selected, because 3 minus 1 2, so 1 comma 2, 1 comma 2 means this rows will be selected, 4 5 6 and 7 8 9. 3 2 and 3, there is no index 3 with the there is no index with index value as 3, so there will be an empty array. So this is the three portions we will get output. We will have the 1 2 3 as one split, 4 5 6 7 8 9 is another split, and there will be no split possible for the index 3, so one empty array will be written. Okay, so this is way you can do the splitting. Okay, that's all for today. We will see two more operations like joining operation on numpy array in the next video or next class, or we will see the concatenation, correlation and linear regression, how can we calculate through numpy library. We will see all these concepts in the next class. Thank you so much. If you have any doubt, please note down the slide number, send it to me with your doubt. I will get back to you on this email ID. You have any suggestion, you may ask me or suggest me on this email ID. Thank you so much. Have a nice day.